We're going to start chapter 5, ladies and gentlemen. It's called alkenes, which means there's a C in every molecule. And we got 5 new groups that we're going to see in this chapter. That's it. Last test, we had millions of new groups. Seriously. You have the ability of naming millions of groups from what you learned on test 1. Because you had that system with the parentheses and then numbers inside. Possibilities are almost endless. Here, only 4 new groups. New groups. We got this one here, where it's just a double bond off of a chain, and it's called methylene. So it's like methyl, but it's got a double bond. That's not really the origin of the name, but for us it works. Next one has an extra carbon, and it's called vinyl. What I didn't tell the morning section is it can also be called ethenyl. That makes sense. Ethene's the molecule. What's the group? Ethenyl. Ethenyl. How do you get groups names? You change the end to -il, right? But vinyl's a name you have to learn because it's so common in organic chemistry. If you don't know it, you're going to miss out on a lot. Add another carbon before the double bond, you get what's called allele. The other system would call it 3-propenyl. That's the systematic system. And our final is this one. The most common one by far. Phenyl. And it's the same as, it's so common, it's got other short forms. No, exactly equal. Same as F. Same as C6H5. Those are short forms. Here's the unfairness of nomenclature. Teacher gets to use the short forms on part 3. You never get to use the short form. Like F and C6H5. Don't put them on your part 3 ever, ever, ever. You're not showing me that you know what they look like. The nomenclature, you're showing me you know what they look like. I want to see the first one only from you. This one. That way you're telling me it's a cyclohexane ring, but it's got double bonds and single bonds alternating around, doesn't it? Okay. So yeah, and a little reminder here, you're not permitted to use short forms on nomenclature questions, even though the teacher's allowed. I know life is unfair. Yet another reminder. We're supposed to draw 2 molecules. Wow. Let's try to make some room. Here we go. R 5-phenyl 5-vinyl undeck 1-ene. What the heck does that mean? Undeck 1-ene. CCC 1 to 2. That's what that means. Right there. You can also do this. That ending is the same. You can move the 1 to in front of the undecking. So you only tell me the first number for the carbons in the double bond. I understand the second one has to be 2. There's no option on that, okay? But you won't see the 2 ever in the name. Unless it's 2 undecking. What alkene, what carbons are involved? If it says undeck 2-ene, tell me the 2 carbons in the double bond. 2 and 3. Yes. We had a question.
Okay, what if there is 2 undecking?
Then it's double bond between 2 and 3.
Oh.
3 undeckings between 3 and 4.
Okay.
So it's understood. It's the number you see and the next one. So draw me 11 carbon. 2, 4, 6, 8, 10, one more. Go to carbon 5. I think 1, 2, 3, 4, 5. If I start from the right, I got more room in the bottom than the top. So we got this and this. What am I going to put on that carbon 5? 1, 2, 3, 4, 5. Yeah. Hey, how do I draw a phenyl? Don't put pH. Don't put C6H5. You're going to lose a half point. Draw me a cyclohexane with double bonds alternating with single bonds. Right? And how do you draw a vinyl? Sadly, our new groups don't even go alphabetically, do they? They don't even go reverse alphabetically. The smallest one is just the double bond to the chain. That's not the one we're talking about. Vinyl is an alkene, and only an alkene. Draw me an alkene. Do your 1, 2, 3, 4. Tell me why this is the 1 and this is the 2. Stereocenter. 1 has 3 more bonds to C, and 2 has only 2 more bonds to C and an H. H loses to the third C. Where's the 3? Is it on the left or the right up there? Yeah. If I connect 1 and 2 and 3, it's counterclockwise, which gives us the wrong answer. So put 4 on a wedge. Wedge all the way. I was very pleased. I think only 2 people stopped their wedges or dashes early on the out of both sections. It's not bad. I had to remind them that they added a new carbon by mistake when they did that. Took a quarter point off or a half point, depending on how serious it was. There you go. That one's done. Nice. Oh, this time I put the number in front. That means the double bonds between what 2 carbons? 8 and 9. Good. Oh, sorry. Yeah, good thing it doesn't change my stereocenter. She correctly pointed out I forgot the double bond between 1 and 2. So I did, didn't I? Look, 1-ene. Where is it? Needs to be over here, right? Oh, it did change my priorities. Oh, I'm in trouble. I'm in trouble. Double bond between 1 and 2 switches the 4 and the 3, doesn't it? That's okay. Don't just erase the 4, erase the wedge. Oh, my goodness. Try to pick the same color.
So the priority for the double bond?
Well, I'll break down the priorities for you in a second. That's the 4. It needs to be on a dash. 1, 2, 3. No, it was fine, wasn't it? Coincidentally, it was fine. No, I didn't change the numbers, did I?
No, you have to put it up.
Some days, you know, the brain appears to be there, but it's not. This is the 3 now, right? This is the 4 now, right? If you leave it on a dash, then it's that. Oh. So you make your dash into a wedge, and then you get your fat eraser out again. That's a dash. And she wanted to know why 3 and 4 were 3 and 4. So here's the deal. 4 is coming out here, and 3 is here. CH2 once, and then twice, and then 3 times for this guy, down to a CH3. So that right there loses to this one, which has 2 bonds to C and a bond to H. Same distance away, correct? Same distance away. That's how you break down a double bond. It's treat it like it's two single bonds. So you're comparing two H's. Sorry, first you compare a C to a C. That's a tie. The C ties this C. Now you're forced to compare a pink H to, it shouldn't be a pink H. It would be a blue H. Compare that. Highlighter blue. Compare this to this. Which one's the winner? Win. Lose. That's why we have the 3 on the top right and the 4 on the top left.
Why don't you think about the longer chain and the heavier?
No, that gives you the wrong answer. That's why.
No, because the
He said the longer chain should have the higher number. The longer chain is to the left. No, one atom at a time until the tie is broken is the only rule. Do not invent new rules. Okay, one atom at a time. If there's tie, move on. Okay, so you break the tie. Next one, we got to do our dot. I'm going to do the answer above. Bicycle rules are always the same. 2, 3, 4, 5, 6, 7, 8. And 5. 1, 2, 3, 4, 5. And 2. 1. Uh-oh. I put myself in a corner here. 1, 2. How do you like that? It's right through the name.
It doesn't have to be inside the cycle.
No, there's no order here because, hey, if it was inside, what is it now when I rotate the molecule? Oh, it's in the middle now. Oh, what is it now? It's on the left. Oh, what is it now? It's on the right. The same thing. Molecules don't know direction. All right, you decide 1 and 10. 1, 10, 2, 9. And then we're going to need to know where, well, no, 13 is. So after you've done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where's 11? Middle or bottom? Middle. 12. How do you draw a methylene? It's our first one. CH2, right? 13 methylene. How do you draw allele on 1? How many carbons in a row? 3. Where's the double bond? On the as far away as possible. Distal. How's that? Distal double bond. That's a biology word, isn't it? I like it though. Proximal means close, distal means far. What about the old phenols on 9 and 10? You got to draw them out both times. 10. Whoa, dude, I had it on 10. Okay, and 9. And there's a group on 8. How's that one look? Well, you know. The question is, there's a double bond between what 2 carbons? Give me the numbers for the 2 carbons in the double bond in the ring. It's at the end of the name. 8 and 9. The question is, do I want to put the group up or down? And the reason it's going to go down and look terrible has to do with that the letter E that is seen here, and nobody's read about it yet, I'm pretty sure. I'll explain it in a second. We'll do the stereocenters first. We'll do a quick EZ lecture underneath this. And then I'm going to leave it up to you to look at this morning's lecture for the cis-trans version of the same geometry of alkene. Because cis and trans is pretty easy. EZ is not pretty easy. Sounds like it is easy though. cis and E and Z and trans are not related at all. But EZ is related, they're opposites. Cis and trans are related in a different way, and they're also opposites. It's about the chain. Okay, so trust me, the E is correct. Save the lecture for that later. Let's do the stereocenters. One has to be R. We're going to go like this. CH2 once, then C with 2 bonds to C. Red has already been used. Purple. A CH2 that goes to a CH2 that goes to a C with nothing but C is going to beat. Oh, somebody is making an argument right now. That should be the 2. Let's figure out who's right. I think somebody else was right. Okay, let me break it down. The bottom one should be 2 because it goes CH2, CH2, C with nothing but C. This is also CH2, CH2, C with nothing but C. But none of the C's attached. Where am I at? We're comparing this one to this one, right? None of the C's attached to this has an H, unless you're looking at 11. But this beats the H's here. I think I got my answer, don't I? Those H's are losers to this C here. So she was right. That's not a 2. I want to erase. That's a 3. That's a bit on the tricky side. 4 is upstairs. And already, oh no, it's S right now. 1 needs to be R. So what's your strategy? 4 on a wedge. I like it. Just came right out with it. And then adjacent for the dash. This looks very adjacent. This is adjacent, but it just doesn't look very adjacent, right? I mean, I'd accept it. I definitely would not accept that for the dash, this one right here. Okay, going over here. Oh man, this is a tricky little stereocenter too. Both these C's have nothing but C, right? But every C you go to next on this thing has H's. Do you agree? Nothing next on this has H's at all, right? Whether you go to the right or the left. We always want to compare the best. So C with no H's is going to beat C with H's. C with no H's, it beats C with an H. So the stereocenter here, we're liking the 1 here. We'll go with we got. Yeah, we did purple. 1, 2, and 3. Which C? Oh man, and we're back to the same 2, 3 as before, aren't we? The reasons haven't changed at all. The CH2 is symmetrically situated here, isn't it? 1, 2, 3 is already, it's clockwise and it needs to be counter. Oh, it's a 4 on a wedge again. Where's my 4? I didn't label it right. It's because these numbers are higher than the 2 and 3 down there. So add 1 to each number. You're confusing us, Dr. Whitaker. Add 1 to each number, and I don't want to erase vinyl. This is awkward. Can't do it. That's a 3. This is the 4. 1, 2, 3 is clockwise, and it needs to be S. The fat 4 is on a wedge. Adjacent for a dash. There you go. And before we finish, I'm going to talk about EZ, but with a better drawn double bond. Now this thing's going to say, you can't leave me there. Thank you. And EZ. Let's do C8. No, let's not even do that. Let's do it this way. Let's do a pictorial version. Step 1. Tell me what I did during step 1. What did I do for step 1? I didn't really do anything, but what did I do? I just put the H's on that they're allowed to be missing, but you need them for EZ. So I put them on. Step 2. I didn't get the bonds. Close enough for, oh. I didn't get a lot of stuff there today. Step 2, tell me what I'm doing here. It's an imaginary thing. Describe it so you can remember it. What did I do? I did a pretend cut, didn't I? Just a cut. And that's supposed to be a 2. And I'll put 3 in red so I can save a little time. Okay, 3's in red. And it shouldn't be, oh, 3, unfortunately. It's not a new thing. It's just done in a different way, isn't it? Where do you think I got those numbers? Take a while to get. Same as Stereocenter Rules. This is Stereocenter Rules, but just do each side of the double bond, 1, 2, 1, 2. And the only question is now, are the ones, listen to how I ask this question, because it answers the question too. If the ones are on the same side, guess which letter it is? Nice guess. They guessed Z. How could you do that? Okay. And if the ones are on opposite sides, guess. E. The ones are on opposite sides here. You actually have to cross the double bond to get from this one to this one. That's a cross, right? So this one is called E, 1 bromo, 1 propene, and the other one, guess what it's called? Take a wild guess. Z, and I'll show you why in a second. The one is on the same side as the other one. That's Z. If you don't like the same side thing, it's vowels and consonants. That works too. E is a vowel, right? Opposite starts with a vowel. Z is a consonant. Same. If you don't like my same, go same. It's a consonant as well. And there you have it. You got to follow all the steps. 1, 2, 3. And then you get your answer. And watch the video this morning. The cis-trans is much straightforward. It's all just about the chain coming into the alkene and the chain exiting. And the video just, this is visual that should stick with you. And